Very good morning, students. Myself B K Singh, your chemistry teacher from Oriental Public School, Kisarganj. Students, today we are going to discuss the change of state. So, change of state. When a solid is heated, it changes into liquid, and when a liquid is heated, it changes into gas. When a gas is cooled, it changes to liquid, and when a liquid is cooled, it changes to solid. Example we can take, that is, if ice is heated, student, it changes into water. And further, if water is heated, it changes into steam. And on reversing, student, that is, if steam is cooled, it changes into water, and if water is cooled, it changes into ice. So this can take place in reverse way also. The question is here, student, that why does the change in state takes place? For this one we can say that this one, it is because of change in interparticle spaces and interparticle forces, which we have discussed in earlier classes, that interparticle forces are also, we can say, the interparticle forces of attraction. So if a solid is to be converted into liquid, the interparticle spaces have to be increased. Similarly, if a liquid is to change to the gas, these spaces have to be further increased. Or we can say that one state of substance can be converted into the other by changing interparticle spaces. They actually change interparticle forces of attraction also. So here the point to be noticed that the process can be reversed also under suitable condition. This is known as interconversion of states of matter. So see this student, the change of state of matter can be done by two ways, and these are, number one, by changing the temperature, and number two, by changing the pressure. Now students, will discuss the change in states from solid to liquid, which is also known as melting or fusion. So students, when a solid is heated, the particles begin to vibrate with greater speed and begin to move more freely. Then at a particular temperature, the solid melts and changes into liquid. The process of melting is also known as fusion. Now we'll define what is melting, or the conversion of solid into liquid state is known as melting. Students, now we'll define what is melting point. It can be defined as the temperature at which a solid melts is called its melting point. For example, the melting point of ice is 0 degree Celsius or 273 Kelvin. And after this student, we will discuss the latent heat of fusion. What is latent heat of fusion? So student, the amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is called the latent heat of fusion. Actually, before that we can say one thing more. The latent heat are of two types, student. That is, one is latent heat of fusion and second is latent heat of vaporization. So just now we have discussed the latent heat of fusion. We have just defined the latent heat of fusion. So student, actually how it happens? Actually, once the melting process starts, the temperature of the thermometer becomes constant till the whole of ice melts, and it is quite surprising that there is no increase in temperature, though the beaker is still being heated as before. Where does this heat energy go? We can explain that as long as ice has not melted, the heat energy supplied increases the kinetic energy of the particles which constitute ice. As a result, the temperature rises, and once the process of melting of ice starts, the heat energy is now consumed in bringing about the changes in state from solid to liquid. And we can also say that the heat energy is used up to overcome the intermolecular forces of attraction present among the water molecule in ice, and thus it is absorbed by ice without changing the temperature, and this is known as latent heat of fusion, which means that it is in the hidden form, as it is not visible. It do not appears because when we heat it and thermometer is present, so we cannot see the change in temperature. It remains constant, and the word latent means hidden. That's why this latent heat is also said as hidden heat. So we have defined this. We can take one example of latent heat of fusion. For example, latent heat of fusion of ice is 335 kilojoule per kg. This means that this much amount of heat is absorbed by 1 kilogram of ice when it changes into water as its melting point temperature 0 degrees Celsius. So students, when a liquid is cooled by lowering the temperature, the particles lose energy and kinetic energy decreases. They slowly come closer and interparticle species decreases. If the lowering of temperature is continued, a state is ultimately reached when the liquid changes into the solid state. This is known as freezing. It is just reverse of melting. And after this, student, we will discuss boiling. So what is boiling? First we will understand what is boiling. So student, when a liquid is heated, its particles begin to move even faster. Then at a particular temperature, the liquid begins to boil and change into gas. So thus boiling is a bulk phenomenon, and when a liquid boils, the bulk of the liquid changes into vapor. So thus we can say the process of conversion of liquid into gaseous state on heating is called boiling. For example, the boiling point of water is 100 degrees Celsius or 373 Kelvin, and this temperature is known as boiling point. So we can define boiling point as the temperature at which a liquid starts boiling is called its boiling point. After this, student, we will discuss latent heat of vaporization. As we had discussed earlier, first type of latent heat, that is latent heat of fusion. Now we are going to discuss latent heat of vaporization. So definition is the amount of heat energy required to change 1 kg of liquid into gas at atmospheric pressure at its boiling point is called latent heat of vaporization. It is interesting, students, that what we have noticed in the melting of a solid also happens in the boiling of a liquid. It means that once the liquid starts boiling, its temperature does not change although it is still being heated, and the explanation is also similar. As long as the liquid has not boiled, the heat energy which is supplied increases the kinetic energy of the particles present in the liquid. As a result, the temperature rises. But once the liquid starts boiling, the heat energy is now being used to bring about a change in state from liquid to gas or vapors. It is known as latent heat of vaporization. Now, students, is there any significance of boiling point temperature? The answer is yes. Just like melting point, the boiling point temperature of a liquid also help in comparing the magnitude or strength of the interparticle or intermolecular forces present in them. Greater these forces, more will be the boiling point temperature of the liquid. In general, low boiling liquids like petrol, ether, acetone, etc. have weaker intermolecular forces as compared to the high boiling liquids like water, carbon tetrachloride, etc. The low boiling liquids are also known as volatile liquids. Students, one very important thing. We have seen that the rise in temperature brings about a change in physical state of a substance from solid to liquid and then to gas. This is mainly because of increase in the interparticle species or decrease in strength of interparticle forces. The process can be reversed if the temperature is lowered or decreased. The gas will first convert to the liquid state, and then on further cooling the liquid state will change to the solid state. This happens because the interparticle distance or space decreases and interparticle forces increases when the temperature is lowered, and the reversible phenomena may be can be said as interconversion or state of matter. Okay, student, now we will discuss that we have so far studied that upon heating, a solid initially changes to the liquid state and then to the gaseous state when the temperature is increased. The process or the change of state can be reversed when the temperature is decreased. However, there are some exceptions. Certain solids directly change to the gaseous state upon heating without passing through the liquid state. This is called sublimation, and the substance obtained on cooling the vapors is known as sublimate. And sublimation can be defined as the change of state directly from solid to gas or from gas to solid is called sublimation. Example, if solid camphor or ammonium chloride is heated, it changes into vapor. If the vapor are cooled, it changes into solid. So students, there are many examples of substance which undergo sublimation. These are naphthalene ball, camphor, iodine, ammonium chloride. These are some common example of substance which undergo sublimation. Students, there are some applications of sublimation. What are these? Actually, the process of sublimation can be used to purify the impure sample of substances which undergo sublimation and are associated with non-volatile impurities. For example, an impure sample of naphthalene containing the non-volatile impurity of common salt, that is sodium chloride, can be purified by the sublimation process. Pure naphthalene directly changes from solid to vapor, whereas sodium chloride is left in the dish. The vapor gets deposited inside the funnel upon cooling. The solid naphthalene thus formed can be scrapped. So we have studied in detail that change in physical state which substances undergo when the temperature changes. Okay, we have also discussed the process of sublimation, which is somewhat different. Okay, student, for watching this video, thank you. Have a nice day. Stay home, stay safe.